Hello, today is Wednesday, October 2nd, 2024. I'm Tony Mangino from TC2, and this is Staying Connected. I'm joined today by David Lee, TC2's Technology Director, and Brent Knight, a Senior Consultant here at TC2. In previous episodes of Staying Connected, we've covered the evolving financial and commercial landscape for broadband internet service. Today, we're going to be taking a deep dive into the third leg of the stool, and that involves a discussion on the broadband internet technologies that are really at the cornerstone of the rise of broadband in the enterprise WAN. So to start, Dave, why don't you provide our listeners with some background on what enterprise clients need to know about the technology behind broadband services?
Thanks, Tony. It's good to be back with you on Staying Connected. And just for the listeners out there, when Tony was saying a deep dive into technology, we're going to try to make it interesting and fresh, so don't turn off the podcast at this point. Let me start with a brief overview. Broadband service has been around for decades and delivered in the form of copper-based XDSL from your local legacy carrier or coaxial copper-based from your local cable company. This type of broadband is still around, especially in rural areas and where there isn't much incentive to deploy new broadband infrastructure. However, as broadband technology has improved and costs have gone down for advanced equipment, there have been new broadband and IPTV entrants that compete with the legacy carriers and legacy cable companies. What we've seen is a tipping point for broadband services in terms of being able to provide greater speeds at a much lower cost per megabit per second compared with dedicated internet access or MPLS. Over the past few years, we've seen our Fortune 100 enterprise clients migrate some or all of their MPLS to internet, DIA, and or broadband. And to clarify, our clients are not migrating entire networks, not all of them, to broadband or DIA, but rather broadband is now being leveraged as a strategic WAN connectivity solution more comprehensively, where in the past broadband was relegated to an external, for example, external customer guest Wi-Fi best effort use case. The other key factor contributing to this tipping point I mentioned just a moment ago is a significant investment made in broadband. For example, the multi-billion-dollar joint venture called Gigapower between AT&T and asset manager BlackRock in developing an open access broadband network infrastructure. This is similar to the old municipal fiber networks. This provides the fiber to the premise with multiple ISPs having access and competing for your business. Verizon's recent acquisition of Frontier Communications and Comcast's multi-year upgrade to their network to provide a minimum of 100 meg symmetrical broadband bandwidth are examples of investments legacy providers are finally making. The list goes on.
Okay, Dave, let's talk about the actual technologies that are driving this wave of transformation.
Sure, Tony. I'll categorize these technologies into three areas. First, wireline, fixed wireless access, FWA, and non-terrestrial networks or satellite. For the wireline technology, this has been accelerated by the deployment of fiber in the middle mile as well as to the premise, called fiber to the premise or FTTP, as we'll call it. In addition, the use of passive optical networking or PON equipment is being deployed for FTTP by these internet service providers. Not too long ago, this type of equipment was used by carriers for SONET and SDH solutions, so sophisticated enterprise-only resilient solutions. With this PON equipment and FTTP, 10 gigabits per second symmetrical bandwidth to the premise is achievable. You don't have to procure the 10 gigabits per second, by the way, but the broadband provider has the capability to grow bandwidth and services at your location over time if you need it. As I mentioned, the cost of some of this more advanced technology has come down tremendously, and new broadband entrants have taken advantage of it, and existing legacy providers have been forced to upgrade to compete with them. There are also cable company providers. They've been relying on their DOCSIS or data over cable service interface specifications, been around since the late 70s, the first standard in 80s. But since 2006, which can provide the standard then, DOCSIS 3.0, can provide 1 gigabit downlink and 200 megabit uplink speeds. Or if your cable provider upgraded to DOCSIS 3.1 in your area, then they should be able to provide 10 gig down and 1 to 2 gigabits uplink. There's also DOCSIS 4, which was published in 2019 and promises to increase the uplink speed on the prior 1 to 2 up to 6 gigabits. So there's promise in the cable company environment.
Okay, so what about fixed wireless access or FWA?
For fixed wireless access, which includes a number of technology solutions such as 5G and point-to-point microwave, FWA uses radio spectrum to connect two fixed points, such as a radio or appliance in a facility and the corresponding radio unit or system located at a network cell tower or other provider POP. Typically, the spectrum used are the familiar frequencies used in 4G LTE, 5G from wireless carriers, but also there's private 5G, such as Citizens Broadband Radio Service, or CBRS, available in the U.S. Just a note that there are equivalent private 5G services available outside the U.S. as well. These provide access to the internet in a larger area with a much lower cost to reach the premise compared to the cost of trenching and deploying fiber in the wireline scenario. If you want more FWA detail, listen to my prior Staying Connected podcast with my colleagues Deb Bowling and Steve Rosen. Now, in terms of point-to-point microwave, that provides speeds of 1 gig to 20 gig from the customer premise to the nearest broadband provider POP or facility. And the dish for those things, if you think about it, could be the size of a teacup, maybe 6 inches across and just screwed into the side of a wall. Very easy. The technology has progressed fairly tremendously. Again, this allows the broadband provider to not have to trench to access the premise.
Thanks, Dave. Brent, what's the latest on non-terrestrial networks or satellite? How's that market developed?
Yeah, thanks, Tony. So there's been a growing excitement in the LEO satellite space over the past few years, and it's about to get even more exciting in 2025. First, Starlink, owned by SpaceX and spearheaded by Elon Musk, has been making waves. Enterprise customers are using Starlink to reach their rural and remote locations, many that don't have a wired connection option without spending large dollars on special construction to light these sites. And Starlink's coverage is almost universal, providing an excellent low-latency service option for non-wired broadband internet connectivity. As of August 2024, there are over 6,300 Starlink satellites in orbit. In the USA, Starlink is licensed to operate 4,400 Gen 1 satellites in LEO and has a separate license permitting up to 7,500 more satellites in LEO as part of its second-generation constellation. This is referred to as V2 satellites. V2 satellites download speeds are generally faster than the Gen 1, but the upload speeds are mostly equivalent. And no matter which service option enterprises may choose to deploy, it can be deployed very quickly, typically much faster to deploy than traditional wired connectivity. Another new service that will be offered by Starlink is its direct-to-cell capabilities. Starlink is working with mobile phone providers around the world to provide text, voice, and data for LTE phones and devices. Text message capability was tested and completed earlier this year, and Starlink is targeting next year, 2025, for voice and data service to be available. Another exciting satellite option that's very close to reality is Project Kuiper. This is a broadband initiative started by Amazon. So when should Project Kuiper service be available? The expectation is sometime in 2025, so that's just around the corner. They launched their first 2 test satellites in October of last year with the goal to eventually deploy over 3,200 LEO satellites. The long-term goal is for the service to offer up to 100 gig speed. So far, Amazon has unveiled 3 types of customer terminals offering a range of speeds from 100 meg to 1 gig.
Thanks, Brent. Can you provide some anecdotal client examples where they went from MPLS to the internet, including using broadband?
Sure, Tony. We recently worked with a client to execute an internet-first sourcing strategy that featured a combination of wired broadband combined with DIA and fixed wireless access. By utilizing a broader suite of broadband technologies, this allowed the client to achieve over 50% in solution cost savings versus what they were paying before, and it provided them with an exponential increase in broadband along with network resiliency. Another client example is with a global agribusiness that migrated from a 100% MPLS network to a mixture of DIA and broadband. Their sites were organized into site types based on site resiliency, performance, and cost requirements, and then specific DIA and broadband configurations were developed for each site type to deliver on these requirements. In the end, given the remote nature of some of their locations and the lack of wired connection options, they ended up leveraging LEO satellite broadband to deliver on their requirements. This satellite option was really a true game changer in this instance.
Okay, great stuff. Thanks, Brent. Thank you, Dave, as well. It appears that broadband does in fact have a bright future. While MPLS still has relevant use cases, dedicated internet and broadband will continue to make significant inroads in the enterprise WAN. If you'd like to learn more about these services, or you have other ICT needs, you can contact Dave, Brent, or me, or any of our LB3 and TC2 colleagues by giving us a call or shooting us an email. You can also stay up to date by subscribing to Staying Connected, by checking out our websites, and by following us on LinkedIn.